work on this. Okay. Well, thank you very much, Jeff, and good morning. Glad to be here. And for those out in wherever webland are, we're looking at the energy issues from a tribal perspective. Intertribal Council on Utility Policy was formed about 20 years ago in the midst of the tribes working out issues of water rights, basically on the Missouri River. And about 24 tribes came together, maybe 28 tribes, all with water interests in the Missouri River or sitting in the Western Area Power Administration service territory that might be served by hydropower. And once those water rights, that water went through the dam, one of the benefits coming off of that whole system was hydropower. It's been cheap hydropower, low cost, federally subsidized, coming off federally powered dams operated by the Corps of Engineers. But the tribes were never able to buy that power directly. Other governments could and did. Tribes never could. So tribes really couldn't build an economy on that low-cost hydropower the way other folks in the region were able to do that. So one of the issues that we raised and one of the solutions that we found was for the tribes to be able to buy hydropower, federal hydropower, at that lower cost rate that everyone else could get. Tribes were qualified from the 1934 and following on their federal power acts. We were act beneficiaries. We are preference customers, but because we weren't utilities, what statute giveth, regulation taketh away. So we tried to address that by saying, look, you've got to be able to find ways to deliver hydropower so the tribes can buy it directly for their own use. So once that water right and that liquid water went through the dam and became electricity, hydropower, it was no longer a water rights issue. So Intertribal Council on Utility Policy was formed out of the northern part of that whole process, and we've been working with federal agencies, NASA on climate change, WAPA on hydropower, Western Governors Administration on policy recommendations to address all of these kinds of issues. We've also been very much involved in looking at energy efficiency, straw bale housing. We've got a tremendous need for housing in Indian country. Probably close to 500,000 houses are needed throughout the United States. A great area. If you're more energy efficient, you don't need to have as much electricity. You don't need as much generative capacity. So we've put our plans out there. We happened to win the 2007 inaugural World Clean Energy Award, awarded in Basel, Switzerland. We were the only North American group to be included in that international level of awards. 9 awards were given. We got the special award because we didn't fit any of their other categories. We got the award for courage by putting out a plan and a way for the country to actually reduce its carbon footprint and build Indian energy economies around renewable energy and help modify the climate in that carbon reduction model. We work with tribal colleges with hands-on and classroom training in wind power, solar power, straw bale construction and the like. So we're engaged on these many levels. One of the areas that we worked with was in the 07 Policy Act, 2005 Energy Policy Act. Congress authorized the Corps of Engineers, Western Area Power Administration, and the Bureau of Reclamation to look at how could you integrate tribal wind with federal hydropower. So those 3 federal agencies, DOD, DOE, and DOI, all were participating with the tribes to see how that Missouri River electrical grid system operating off the dams could work together with tribal wind integrated into that system. So this study was authorized, $1 million was authorized to do it, and not one dime was appropriated to do it. So here's a great idea. Congress mandated it be done within a year, but didn't provide the money to do it. Western Area Power Administration found some dollars. They put together the study. We participated in it. There are problems, there are shortcomings because it was never adequately or properly funded, but it was done, and it led to a number of very good insights and some good recommendations, which we'll get into in a little bit. What we've seen, though, is that we need a supplement, and we've petitioned the feds from 2009 forward, 2011 here, asking for a supplemental study. And part of that supplement could well be a serious look at what the prospective climate over the next 30 years for the Missouri River Basin might be. We've got these kinds of analyses done globally. We need to bring them down in some resolution for the region. We think it would have benefits not only to the agencies that are shown here as part of the wind hydro study, Interior through Reclamation, Corps of Engineers through Department of Defense, and WAPA through Department of Energy, but we think that a study done in that north central area where the DoD Climate Science Center is being located, that's the entire Missouri River Basin is included in that a couple of other agencies might have a dog in that hunt, knowing what the climate might look like, how much water might be here, how the drought may strike the region, and have implications for all of their programs and the like. So I'm going to Washington, D.C. next week for a meeting in the White House to talk about some of this stuff. So we're glad there's at least an ear for that. What I'm going to talk about today is tribal strategies for resilience in the face of weather extremes. How many people here believe in human-induced climate change? How many people don't think humans are involved in changing the climate? Okay, if this was an audience of people who are not as elegantly schooled and up to date as you folks, you might find 15, 20% of the people may be deniers. We found actually that more folks have recently come to appreciating that maybe global warming could be real. 3 weeks of triple-digit temperatures this past summer has even in the brain moved heat and warming. Maybe there's a connection. But it doesn't really matter what you believe because climate change isn't faith-based. What you do about it might be and how you do it, but itself is physics, and I'm not going to go into that. But instead of talking about climate, we talk about weather extremes because where the rubber meets the road is how do you deal with that? How do you mitigate it, and how do you adapt to these changing environments? So we're going to go through this, talking a little bit about climate change and the extremes, how wind and solar systems might be able to be a great mitigation tool, and tribes can be participants in that, how stored fuel from renewables, moving it from intermittent to dispatchable, may be a very important technological approach to dealing with our energy needs, both as stationary energy for electrical generation, for lights and all of that, for transportation, and for agricultural input. Ammonia is one of the largest inputs into the U.S. agriculture. Most of it is formulated from fossil fuels by moving the carbon off into the atmosphere, just stripping it off there, and then making the NH3 out of natural gas. We could look at making carbon-free ammonia and utilizing that liquid reservoir of a storage medium to meet our dispatchable energy needs. We turn it on and off. Problem with a wind turbine is it may not be generating power when you want the lights on. So finding a way to store that becomes very important. And then finally, I'm going to talk a little bit about the straw bale work construction for housing. The built environment has a tremendous impact on our carbon footprint, and there's a big difference that we can make, especially in Indian country. Okay, the first on the climate piece. Am I going the wrong way here? No, there we go, okay. The rest of the world live the way we do in the U.S. This is how many planets we would need. This is the resource base we would need for our current population on the planet to live the way we do. Chances of this happening? Slight. we're going to have to adapt. The whole world can't live our way, and we're not going to be able to live our way very long for all sorts of reasons. Short course on climate change. Everything flourishes where it does, by and large, based on the temperature and humidity that it gets on a daily cycle, monthly cycle, annual cycle, seasonal cycle, those kinds of things. But changes in temperature can change the amount of humidity or amount of water available to us. It can change how that water behaves in the environment. We were talking a little bit earlier, a warmer temperature atmosphere can hold more moisture until it cools. And then all of that more moisture falls at the same time. Cedar Rapids had 2 100-year floods within 5 years. Not that's ruled out by a 500-year flood. That's a statistical thing that it could happen every year. We had the 500-year flood on the Missouri River this past year, 2011, after almost 8 years of drought. So we had the lowest record Missouri River level. It was broken twice in this last decade. Lowest, and then even lower than that. And then we had the ultimate highest 500-year flood. We've never seen that. We've only been keeping records since 1906. So rather than talk about climate, weather extremes certainly fits the bill. No one can deny it. There are no weather deniers, and everyone has a story. Each and every one of you is an expert on the weather. The resource rate that we use, the rate that we use our resources is tremendous. 4,500 years ago, this was ore. Native copper came out of the ground in big chunks. People hammered it, traded it to the Gulf of Mexico from the Upper Peninsula of Michigan. Today, ore is measured in 0.1% of rock because we have the energy to grind it and extract it. But that's the resource difference. This is extremely energy intensive. Native peoples vary from Western civilization, Western science, and the like, with an outlook. Usually the West folks look at forest of trees, and we can appreciate it as a forest, but economically, board feet seems to even be more important. It's a resource. Tribal people have seen the resources, things we call resources, more as relatives. And it's the relationship you have with it. And if ecology teaches us nothing, it teaches us that relationships within a system are more important than any one of the individuals. We seem to think the individuals are more important. We are the keystone species. We've got to see our place in a much bigger system. So I'm on the call too. This is an actual sign, street sign I found in Nebraska, eastern Nebraska. And I came to it one night. It was raining. Took this photograph, kind of drizzly. But it was 2012. The end? Or which way do we go? I don't know. Yeah. This raised this question. There's a lot of uncertainty. There's a lot of things we don't know, but let's see what we can do about that moving forward. When we look at climate and what's been proposed for us to understand it, we're talking by 2100, places like New York or some of these other states are likely to have much climates that are found currently in much more southern states. Rosebud Reservation up there in South Dakota may have a climate looking like central Texas. Thanks, but no thanks. We'd rather not, but if that's where we're headed, we're going to have to make some adjustments. We're going to have to make some adaptation. We're going to have to get ready for that. So tribes have been looking at the issues of various crises, but we don't see it stovepiped. We're not the tribes of climate. We're not the tribes of energy. We're not the tribes of housing. As communities, we're holistic. Our needs are community needs, and all of these things are at issue, and we start looking at ways of dealing with them in ways that make sense to these various crises. I showed this once. I put it up together on a Mac, and I showed it on a PC, and it came out like this. It's sort of just swap things around. And I looked at that and I said, well, maybe there's some value in this. And when I looked at it, I said, oh, this isn't transferring directly. But in any case, if tribes could get really energy efficient and built out a whole pile of renewable resources, if collapse comes, if the whole grid goes down, we may be these islands of sustainability where the lights are still on because we're not dependent on those central stations and the like. The Northern Plains provides a great opportunity for new industry. We are, according to The Economist in 2005, we are America's poorest region. We're Americans' ghetto. And they're not even talking about the reservations. They're talking about the non-Indian economies and populations. If you look to the Indian economies and populations, the darker the coloration of the county, the worse the situation, either personal income or unemployment. All of those dark counties are on Indian reservations. 7 of the 10 poorest reservations are in the Dakotas. 10 of the 7 poorest counties are in the Dakotas. So we are also looking towards the future and the fact that the U.S. population, according to 2010 census, the median age is about 36.9 months. Who here is older than 36.9? Okay, there's only a few people. Most of you are young, according to the U.S. average median age. On a reservation, or for all Indians, it's about 29, almost not quite 10 years younger. On the reservation, half of our population's under 20. How many people who are under 20? You're now all old-timers if you were living on a reservation. You're on that top half of the population. And you start looking at employment issues in Indian country, we've got 60 to 80% unemployment now. In 10 or 20 years, we're moving another half of our population into that job market. What are those young people going to need? Jobs, houses, food, water. Maybe there's some opportunity to start building in terms of local economies in those directions to make our communities more resilient. Looking at the renewables, wind and solar primarily, but we've got geothermal, we've got biomass, we've got all of that. But looking for ways to be able to use these as mitigation measures to deal with both short-term and long-term weather pattern changes. We can do this. Pat Spears, our president of Intertribal Gough, he just passed away this past summer, so it's been a hard year for us. We've been sort of reorganizing a bit. But he worked with the Clinton Global Initiative, bringing these issues of clean energy and safe housing and energy-efficient housing to the point that we're now working with the Clinton Global Initiative in America here to begin to address some of these issues in Indian country. In terms of renewables, we've got them all. The sun shines on every reservation. The wind may not blow as well in one place and more so in another. Geothermal may or may not be found there, depending on how deep you go. But biomass, all the reservations have some piece of it, at least, and some are multiply blessed. A few have some major fossil fuel and carbon-based energy resources. Some have uranium, but most don't. Almost all have some variable, some portion of this that can make a difference in their local economy. And when you look at the peak coal, this happens to be the Hubbard curve for the UK in terms of coal. They peaked out sometimes in the early 30s. I saw that curve and I said, I've seen that somewhere else before, and I realized it's the dinosaur economy. And we base our current economy on the dinosaur periods. Millions of years ago, stored up solar power from the age of the dinosaurs. We're releasing that now. But those dinosaurs lived in very different climates than we have today. And where we find those bones in Wyoming and the Dakotas, you couldn't support dinosaurs there today. But we're putting enough carbon back into the atmosphere that, who knows, maybe we could soon. I'm not sure I want to go there either. These are some energy charts of conventional forms of energy, coal, gas, oil prices, uranium prices, and by and large, they go up and they come down a little bit, but they never quite come down to where they used to be. Then they'll go up again and come down, come up again, but the trend is heading upwards. And you look at renewables, the trend seems to be coming down. So which energy horse do you want to be riding in the future? This may be the place where the economics makes a whole lot more sense for your communities. The tribes have gotten together in 1998, 99, looking at climate issues. We put this together in Albuquerque. Climate scientists came to meet tribal people, elders, spiritual people, NGOs, tribal NGOs working on these issues. And we realized renewables are not only a nice mitigation for the climate, it's something compatible with tribal culture and tribal values. Tribes as climate documenters. In the northern plains, there's a phenomenon called the winter counts. Every year, as the communities broke up into smaller groups to winter in smaller groups, they didn't have TV, they didn't have VCRs. They talked. They talked about the stuff that happened that whole year, and they decided to come up with what was the most remarkable event in that whole year, and they recorded it with one little picture for every year. So they kept a yearly account, a winter count, every winter of the most remarkable event of that past year. Those accounts were collected by the Smithsonian in the 1880s, 1885, thereabouts. That's about the time that the thermometer came out to the Great Plains with the military. Our records for the Great Plains don't start until the 1880s, 1890s. These records collected by the Smithsonian ultimately ended in the 1880s, 1890s. But they go back, some of them 200 years. And many of them are weather related. There was the year that the snow, 1723, the year that the snow was over the top of the teepee poles. Anybody here ever see a teepee pole? A teepee set up? Do you know how high that snow would have to be over the top of the teepee poles? And this was recorded not just in one place necessarily, but over all of these winter counts. You could start doing a study of that, and you do it by 1 year. You line them all up, because they didn't put the years on those winter counts, they just put the picture. But when you lay out all those pictures, and you see that 1833, 1834, that was the year the stars fell out of the sky. Massive meteor showers. Everybody saw it. It hadn't happened before like that. That was the most remarkable event for all of these communities. And when you line that up, you can line up all the other winter counts by that same year and see what the climate piece was like, including things like the weather, the over the top of the teepee poles. Or this one here, it's the year they eat frozen fish. Oh, we eat frozen fish. You could chop fish out of the ice in the rivers and in the lakes because it was that cold. That tells you something about at least that piece of the climate in those places. So we've got those kinds of weather histories, if you will, or at least weather event histories. Tribes are still in the business of educating forward their young people in their culture, and we're doing it now through tribal colleges. And tribal colleges arrayed across the northern plains are arrayed just the way the prevailing windshed works, by and large. And we've been talking with the colleges about doing renewable energy assessments, doing climate, natural resources monitoring, meteorological data. If they all did the wind mapping, we'd be able to get real-time data as fronts moved across. And if the tribes also had wind farms, you could then find out when a lot of wind will be getting queued up to get onto the grid. So there's a whole lot of value added in a new energy economy that we need to be training our people for. Now, Pat Spears, who's gone, he's had a lot of great things to say, but one of his most favorite and famous, I think, is we talk to a lot of people about monitoring and balancing, and you've got to really manage the loads a whole lot more carefully if you're depending on renewables that may be intermittent and fluctuating and variable. And the energy people say, well, you know, that's a whole lot of work. And he says, yeah, and we call that jobs. All that extra work, it's jobs. This is where we could put our people together to work in a renewable energy economy. We're working with some of the tribal colleges, looking at internships around climate and the like, working with NASA in this case 2 years ago and last year's class, and I just visited with this year's class down at Haskell. So there's a lot of scientists coming out of the tribal college programs now looking at these weather-related areas. Intertribal Coup has been very much involved in training around renewables, installation of wind turbines, and learning that technology in a hands-on way. And we've got to. The West is coming to a perfect storm, and we know that water and energy are inextricably linked. We spend a lot of our energy moving water in the West, very often to money. It can flow uphill to money. It does a lot of that. But we do a lot of movement, and the energy economy is also dependent on water going through the federal hydro dam system throughout the West. So we've got to see how the relationships work, energy and water and these kinds of things, and what are our roles in these relationships. The Missouri River before the 500-year flood, well, for many years was the principal source of clean water and certainly an energy source when the dams were built. And we found that the dams were built on the Missouri, on the main stem. Power lines were moved across the West, across the Great Plains, and that's where most of our energy came from. Up until that, the electricity came from small wind turbines. Every ranch and farmer had one to generate electricity, but also more so to even pump water as a mechanical energy resource. But once these dams on the Missouri were harnessed, a lot of those other smaller projects were just sort of removed. They bought into the electrical generation system. Well, so much so that dams, you can only build so many dams on a river. And then we had to move to a different river to get our power. And the river we moved to was coal. And now coal, these coal trains provide up to 40% of our electricity nationwide, a higher percentage here. Gas is just moving into that market now, but this has been one of the principal causes of CO2 emissions into the atmosphere, has been our dependency through electricity on coal. It's had other problems. That CO2 accumulation has reduced in many places the snowpack in the Rockies, meaning less water coming through the dams. When there's not enough water behind the dams to make the electricity contracts good that WAPA has for 20 years, it buys more coal. Buys more coal, more CO2, less snowpack, less rain, less snow, less water, more coal. And it's a little vicious positive feedback loop. We think renewables injected into that loop can break that cycle and reduce the amount of carbon emissions of our energy footprint here in the Great Plains. We know that there's other impacts on the biology of the area. The droughts and whatnot have stressed the trees. They can no longer respond to the bark beetles and the like, and we're losing forests that dry and die and burn. And we're seeing that across the West. We think that we should be looking at our hydropower system and our constrained transmission system and maybe find a new way to use it. Right now, up until last year, we were about 85% coal, and because of the drought, just a small percentage hydro. Last year changed it very much for a year, maybe two. We have enough water in the system now. Last summer, WAPA could not give power away. They were running it 24/7, running the generators. The generators only use about 500,000 cubic feet of water per second. The Corps of Engineers was releasing 150 cubic feet per second, 150,000 cubic feet per second. That was the max that they could do, and then they moved it to 165,000 cubic feet per second because of the 500-year flood. Power was being given away at about a penny, 1.3 cents a kilowatt hour, 1.3 cents a kilowatt hour. You can't build renewables into a market that is only, if it costs you a nickel to build a wind turbine, nickel a kilowatt hour to build a wind turbine, you can't compete against 1.3 cents electricity. That's what everybody wanted to buy. So we start seeing that these environmental issues and these natural issues of flooding and the like have real impacts on the kinds of energy systems we're able to bring about. We would like to think about the grid, the capacity which is limited. Bring on all the wind you possibly can. It's the most abundant resource in the northern plains. The most abundant. It's the least dispatchable, however. You can't just turn it on and off. You have to wait for that natural process of the winds coming up. But we get 40–45% wind at 40–45% of the time. So it's there. It's there to be had. We should opportunistically take as much of that as possible and then use our hydro when the wind isn't blowing. So that would be one way to think about managing the water resource, especially if we're moving in more and more into a drought scenario. So, and then you bring on coal. We're not going to get rid of coal completely. We should certainly make it scrubbed and cleaner, but the opportunities of optimizing our renewable energy resources first might be a very wise way to go. In that footprint of Western Area Power Administration, the department that runs the transmission system off the dams in the west, there's over 350 tribes, I think. Over 300 tribes there and another 50 up in Bonneville. We have a lot of tribes that could be building economies based on renewable energy and helping us meet our energy needs without carbon in a drought-constrained future in the West. The wind resources on the reservations are tremendous. These blue dots indicate the amount of wind availability on each of these with certain constraints and areas subtracted. You're not going to build, wall-to-wall wind turbines, but each of the reservations could contribute considerably to the nation's energy supply, and especially on that federal grid. We could actually green that grid up pretty good and keep a lot of the carbon in the ground. It's a choke point. That carbon, that coal, has to use the same wires we want to use for wind and that are dedicated first to hydropower as a government instrumentality from the dams. Tribally, governmentally owned wind projects would also be government instrumentalities. And in that federal government-to-government relationship with tribes, there should be a priority given for tribal wind onto that grid. And then you bring on the coal and everything else that you need. We've looked at this area in the Northern Plains in particular, great opportunity there. The former director of an administrator for WAPA came in 2007, I believe, and basically said he had 3 priorities: transmission, wind, and working with Native Americans. And we've been working with him trying to get these ideas onto the table and get it worked into the operation. But we're working with bureaucracies, and one of the lessons we learned from working with bureaucracies is their motto seems to be, we don't do anything we've never done. Well, we're going to have to do some changes. And part of that was going to WAPA and going to the Corps of Engineers and looking at their 5 and 10 and 30-year plans and look at it and going, this is interesting. Where's climate in your planning? Oh, you didn't include climate in your, so you're holding climate constant. Well, yeah, I guess we are. What if it's not? What's plan B? And the climate scientists are telling you better figure out plan B, C, D, and E, because we may have some very difficult times coming up ahead of us. We've been trying to prepare. The Indian Energy, or the Energy Policy Act, had a chapter, Title V, that had a number of options for how the tribes could work with their government partners, WAPA and the like, using power allocations to firm wind back and forth. I won't go into the details here, but just to let you know that this is not only contemplated in law, it's spelled out that there are these opportunities for the tribes to begin looking at and taking advantage of. One of those was the study that I referred to earlier on the Missouri River Basin. So there's preferences that tribes are accorded. Why? Well, one of the reasons is most of the water in the Missouri River was used by tribes before the non-Indians used it. So under our Western laws of prior appropriation, we're first in right. We haven't quantified how much water we need for our reservations or that we could use off that system, but that's still a wild card out there. And that's something that we're all going to have to address, especially in times of drought. So there's power purchase requirements in the federal system, and tribes can play a role in that. Then there was this feasibility report that was due in 2006. It was finally published in 2009. And it said, yes, even if you had the wettest scenario for the next 30 years, we had floods every year, we could still use about 50 megawatts of wind, and maybe the tribes could find a way to utilize that and get involved in the system. The economic development opportunities for wind in Indian country are tremendous. Great many new jobs could be created, a lot of money getting pumped into those local economies, and it would provide us a nice solution to the whole climate mix. But right now, where we sit, in the Northern Plains in particular, we're in a region where most of that area is controlled by the cooperatives and their networks, Basin Electric. And they are very much tied into having bought into coal generation from the 70s forward, incurred a lot of debt. And they don't want to give up market share because they've got to pay that debt back to the Department of Agriculture, RUS. So it's a very tricky economic climate that we're living in, but we're going to have to make some changes. We think tribes could really lead us out of that dinosaur economy into renewables across the West and make a difference and make a good living for the communities. We had proposed for Copenhagen and then for Cancun and then for Dubai and any place else this opportunity of decarbonizing the federal grid from Indian country. This is something that could be done, whether it's solar in the Southwest or wind in the Great Plains. Great opportunities. We're engaging with the Department of Energy and other agencies looking at the educational needs for tribes, for reservation projects. We're looking at internships through the Renewable Nations Institute to help students graduating get certified in areas of renewables, energy assessment and the like, and actually work on projects on the reservation. For Indian kids, you get educated up, there may be no place to go home to do your project. So you have to get hired somewhere else. We'd like to create those projects so our kids can come back and work in those communities. The tribes on the Missouri River, in particular, have a whole environmental justice situation. When the dams were put in, none of the dams actually are on the Indian reservations. They're just to the south. The dams were put in for flood control. Flood control protects the communities further south. What it does for the communities north is it floods them permanently. We get the reservoirs. If you're an Indian, flood control for you means you're permanently flooded and somebody else is in control. That's not a pleasant place to be in an energy economy. When the renewables comes around for this next round of energy, we want the tribes to be in the driver's seat, at least on the reservations, to at least get the benefit of these projects and not bear all the burden. Because when your community is burdened and someone else gets all the benefits, that's an environmental injustice that the whole environmental justice program in the U.S. is geared on. But we're actually taking it a step further because we're also talking about climate justice. Indigenous peoples around the world. We turn this light on and we burn coal. We're helping sea level to rise in Tuvalu, and island people there having to move to other places to find homes. So indigenous peoples worldwide are the first and worst hit with climate change impacts because climate disrupts stable habitats, intact habitats. and indigenous cultures, depending on subsistence, need intact habitats for those animals and life forms, plants and animals, that they depend on to be there. And if you disrupt those things, you're disrupting the very foundations of their culture. Our plan, looking at where the dams are on the reservations or near the reservations, where that system operates, we'd like to see not wind turbines, not just in some of the areas, we'd like to see them on all of the reservations. And if we use this electrical generation transmission system coming off the dams from central dams, weeding out across the entire 6 states of the upper Great Plains, in sort of a Heyoka fashion. You know, Heyoka is the contrary, the one who does things backwards. If we use this system backwards, we could take a distribution system and make it a collection system. Everybody in this whole region could be generating renewables and putting it into that wire system, and then maybe bringing it elsewhere, maybe even the coasts, to meet energy needs out there from the heartland. We know, too, that an integrated system, like one grid system that has wind on it throughout, wind at a single place has no capacity factor, no real value, because you don't know when the wind's going to come on or off. You can't count on it. But if you had it across the entire system, you would always have some amount of wind getting into the system. And tribes are willing to not just participate in this, but to also be parts of whatever study that might be needed by the DOE to look at how well this could be effectuated. Ammonia, the storage system. Very briefly, NH3, nitrogen carrying 3 hydrogens. What's missing in that in terms of an energy formula of our current contemporary energy formulas? There's no C. There's no carbon. Right now, our ammonia production is based on taking natural gas with a carbon, releasing that as carbon dioxide to the atmosphere, and then using the ammonia. Ammonia is the largest single input into agriculture right now. So the carbon footprint of agriculture could be significantly changed. And if you could make ammonia from renewables, NH3 has all sorts of wonderful aspects to it, but you could make it with a wind turbine. You can make ammonia with a solar panel. You electrolyze water, bubbles out, and it could be salty water, it could be brackish water, bubbles out hydrogen gas and oxygen. You save the gases. Problem of saving hydrogen is that it's so small, it's hard to hold it. It's hard to store it for a long time. The best way to store it is to bind it with something else, make it bigger until you need it. And then you release it for the oxidation, introducing oxygen back to that hydrogen with the emission of water. Your energy is produced. So the wind energy goes into that process to separate it, and then when you want that energy, you call on it, you put it back, it releases that energy. And it's not a one-to-one. There's some energy loss all the time, but there's no carbon at all. So it's a carbon-free process that may be very beneficial. And rather than attach those electrons to a carbon, like carbohydrate, hydrogen and carbon, or hydrocarbons, it's nitrogen. Nitrogen and hydrogen mixed together. And you've got the ag aspect of it, but you could also use it in stationary fuel generation. You could use it as transportation fuel. You could actually run the truck on ammonia and have it deliver ammonia to other generators to be able to burn it, or to agriculture. And you bypass the constrained electrical grid system. You just bypass it completely. So there's a number of aspects to this storage medium that makes a whole lot of sense. But the economics now are coming to a point where creating the hydrogen, or creating the ammonia and formulating it, and then finding good optimized ways of burning it, that's the point where we're at right now. There's developments going on, and they're very exciting. Lastly, looking at these extremes, energy efficiency. Amory Lovins from Rocky Mountain Institute was reading a PUC, Public Utility Commission report, and it's late at night, and his eyes are going a little funny, and he sees the word negawatts. Somebody had mistyped megawatts. Rather than an M, became an N. And his genius was recognizing the value of what that word meant. Negawatts. It's the energy you don't use. Oh. How much do you pay for a negawatt? You pay for it once in efficiency, and then you never have to use it again. You find a way to collect solar energy through your windows by orienting your house to do that. You only have to pay for that house orientation once when you build it. And once you do, you'll get it every day for free, delivered right to your window. The cost of that is, the savings of that is tremendous. So this whole idea of negawatts in the built environment particularly makes a whole lot of sense. This is Indian country. We've had about 40,000 years of green natural building housing in Indian country. We've had about 200 years nationwide on disaster relief, trying to figure out ways to house a bunch of people that have been taken away from their larger, bigger environments where you might have built your house from the backs of a buffalo, the hides of a buffalo. If you no longer have the buffalo, you can't build your house with that. Tar paper was introduced to replace the buffalo hide. Doesn't quite work as well. The soup isn't any good. Tar paper soup is just no good. So people have had to transition. People have had to make changes. But they've had a wide, deep experience in natural building. Green economies. 40,000 years, except for this 200 years of disaster relief. And guess what? With climate change coming, we're all heading to an era of disaster relief. More natural disasters, floods, tornadoes in Brooklyn, New York, Boston, things we've never quite experienced in the same way before. We're seeing these extremes happening, and we're going to all have to deal with disaster relief in greater ways. More of our budgets are going there. Insurance companies take climate change seriously because they're the ones that have to pay out every time one of these natural disasters hit someplace. So the diversity of housing, the built environment in Indian country, this is what we've had. This is where we come from. Today, because of federal programs, no matter where you go, you can find the same house in Indian country. The opportunity of doing, since about the 65, 70, the HUD and the like, tribal people need houses. They get a limited budget. Councils have to make political decisions. Do we build a couple of really nice homes and wells insulated, or how many cheap ones can we get? Because I've got a lot of people, and my election depends on supporting a lot of people getting houses. Give me as many houses as I can as my budget can buy. It doesn't buy you the quality. Doesn't buy you, and it ignores the fact that your cost of your house is not the upfront purchase build price, but it's how you operate it over the next 50, 60, 70 years. That cost has to be tabulated right here when you build it, because it's a one-time cost investment. And if you do it right, you'll do a whole lot better off down the road. The sod houses were built along the Missouri River areas where the grounds, where the soils were richer, very organic. When you move further west, western Nebraska and into eastern Colorado, didn't work so well. What people then did around the 1880s, with the invention of the baler, they took meadow grasses and straw, and they would bale them, and they had these bales. It's like, we haven't got a lot of trees, can't make log cabins, ground's no good for soddies. We could use these as bricks, straw bales, hay bales, and they did. And this was a house that was built in 1903. The photograph was taken, it was abandoned in 1956, and the photo was taken in 1994, almost 40 years later. We're about 50 years later now. This house looks pretty much the way it does right now. 3 good weekends, you probably could be living back in this house. And I'd ask any one of you to go on a reservation and show me a HUD house that could be abandoned for 50 years and look anywhere near as intact as that. We don't have them. So when you start looking at green housing and public housing in particular, because tribal governments have more to say about housing on their reservation, the built environment, because most of the residents are at an economic level that they qualify for public assistance. Fort Collins has people who qualify for that, but it's not everybody. And they may have public housing, but it's not the whole suite of housing. They control it with zoning. Tribes sit in the driver's seat. They can direct what designs are built, who builds them, where they're built, how they're built. There's a lot more power in control of the built environment, which is a major part of the whole climate and energy equation. You look at the need for housing in Indian country, tremendous need. 2003, Civil Rights Commission said we need 200,000 homes. Today it's probably closer to 500,000, 500,000 homes. We've got a great unemployment number. We'd love to put these people to work building houses, especially using local materials. It's like a straw bale that will give you far greater efficiency. When you start looking at this, the national average of where our electricity goes to, quarter of it goes to energy, the rest goes to buildings. On Indian reservations, there's not a whole lot of big industry. Much of it is agriculture, in fact, across the West, or some mining, but not a lot of big industry. Most of our electricity goes to buildings. And most of those buildings are residence houses. And with a growing population, we're going to need more of them. And buildings are one of the hardest areas to bring the carbon footprint down. Industry can bring it down because there's profit to be made. But buildings are a slower process. They're built, they will perform that way for 50, 70 years, 100 years. The turnover isn't as fast as we might like, or certainly not as fast as in areas in the other industries. Then we look at how it's consumed once it gets to the building. And we see it's for space heating, lighting, water heating, cooling, all of these things, cooking. And we realize that 40% about of conventional buildings consume 40% of our annual U.S. energy production. Can we reduce that by things like siting, proper design and siting of the buildings? If we did, we might be able to accommodate up to 70% of those energy uses simply by proper siting, insulation, design. Great opportunities for negawatts right here. One-time expense, and you get the benefit for the life of the building. Passive renewables can be involved here, as well as the siting and orientation and design. Otherwise, this is our housing stock. It's on life support. If the power is cut off, people die. Power lines go down, people can't afford the propane. The propane can't get through because of snow drifts. The costs go up as soon as the first snowflake falls, becomes unaffordable. This is not a good situation. So finding a way to increase and maximize our energy dollars, it makes sense because right now nationwide 70 to 80% of every dollar spent leaves the local community. In Indian country, about 90% of that dollar leaves and we're left with a dime. It'd be a whole lot smarter to use that locally and make sure that happens. Indian country, because of land tenure, we have a lot of trailers, about 30%, because people can get mortgages for trailers. We have FEMA trailers. Here in part, this is back from 1999 when a tornado went through Oglala, community of Oglala. 54 FEMA trailers were brought up. People were homeless, moved into the trailers in the FEMA parking lot, and they're still there today, living in the FEMA parking lot. That's outrageous. These are temporary. These are never meant to be permanent, and they certainly aren't adapted to the cold climate in the northern plains. We did housing charrettes. We came up with designs that people kind of liked. We could build them with straw bale, much larger areas. And when we did this, we recognized this was just expanding a one-bedroom house to a four-bedroom house. And we realized, you know, you could take trailers which are very good in 60 to 80 degrees, but in the Great Plains, we go 30 below, and we go to 120 above. And this past summer, we were up in that triple digits for almost 3 weeks in a row. People were coming into the straw bale house, which we built to protect us down here for the cold winter. They're coming in, and it was 25 degrees cooler. And we didn't even have an air conditioner or anything. It was just the nature of the insulation kept the building cooler. So there's another aspect that we're beginning to appreciate all the more. But that design, you could take trailers, take all the siding and all of that stuff off, straw bale wrap them, and then wrap a big building or big room in the front after you've passively solar oriented the trailer at a new site or different site, and you could come up with that same sort of design that people said in the charrettes that they wanted. So the opportunity for Indian country to look at natural building coming off of the environment and getting back to the natural resources we have, including our youth, our young people, and renewable energy, and looking at this kind of economy can make a real powerful difference. The opportunity of using straw with our very limited timber supply could extend that timber supply, that lumber supply, because you could make 6 houses out of the same amount of logs it would take you to make one if you only do it post and beam and then infill with straw. So it's a great opportunity there. This is what we call our safe homes. Sustainable, affordable because you're cutting your energy bills, and future-proofed. I don't care what you believe about climate change. If we're going to get these weather extremes, build so that the house you're building can deal with whatever extreme comes your way, and you'll have met your climate change concerns. Make them energy efficient for sure. The National Geographic went through looking at the power of straw bale among some other technologies, especially around even earthquakes and the like. But certainly for the issues that we find for insurance companies. 430 tribes, their housing authorities could not get insurance because their sovereign governments and the insurance companies said, I don't want to deal with 565 tribal courts and different legal systems. So they self-insure. They've pooled their money, one insurance company for all of them, and these are the claims they paid out for 2011. Wind and fire and water were the top 3. When you look at wind in the Great Plains, we're in Dakota Alley, for the Tornado Alley for sure. We get winds. We're talking about wind power, no question. We can get damages from winds. A tornado hit about 30 yards from this straw bale building on Turtle Mountain Reservation. It damaged 19 homes, wiped out 12 completely. The metal roof was torn off this one section of this building. Otherwise, that straw bale was so weighty and massively part of the earth that it's tornado resistant. I don't know that you can call something that, but to have one 30 meters away and have that be the minimal damage to that building is impressive. Studies have shown straw bale can deal with gale force, hurricane force winds and the like. Fires. We've had fires breaking out across the West. We had one at Rosebud and just south of Pine Ridge this past summer, threatening houses and the like. Straw bale can pass the 1 and 2 hour fire tests with earthen plasters on either side in that wall system. It makes you very secure against fires in the area. The last was water damage, and it's not from the floods of the 500-year flood. You can't do anything about that unless you move to the top of a mountain. But most of the water damage in houses comes from frozen pipes. Why do pipes freeze? Because they get cold. Why do they get cold? There's not enough insulation to keep them flowing, or you're not paying your utility bill, the heat goes off, and it freezes. People who can't meet their $300 or $400 a month utility bill move in with someone else. The pipes are left alone. They freeze. Water damage to the house. Insurance companies pay out. We could look at these payments that are being made, and for water, because straw is so sensitive to water damage, it'll mold if it gets wet. You don't want it wet. You build around water. You take it into the consciousness to start with, and you're far more careful how you route your plumbing. Plus, with so much insulation, it's likely not to freeze. So here's a way architecturally to eliminate your water disaster payouts. And over 66% of those claims of the whole of that last year could be reduced or even eliminated. Now, insurance companies sort of take that kind of thing seriously, and especially for their owners who happen to be the housing authorities. So this is what we're bringing to them. We're saying, look ahead. There's this opportunity again to build new economies, saving money around these issues of energy efficiency and the like. We can get back here to these leapfrogging the 20th century, that disaster relief period, and move into a new era of more quality energy efficient homes. The oldest straw bale in South Dakota was found to be on the Rosebud Reservation, and one of the newest. We built that as a tribal college project up at Rosebud. So the opportunities are there. We're working with the tribal colleges to get this information out in the Voc Tech classes. A lot of guys there with tool belts, but because it's clay and straw, for the clays in particular, we're also reaching to many of the women who are single moms. Many of them need jobs, and doing the plastering. We're going to the art institutes and saying, think of this house as a big pottery project, and you can sculpt it and you can do all of these things and really express yourself culturally. Great opportunities. So we've done these tribal college projects in North Dakota, South Dakota, bringing other tribal schools into it, hoping that the follow-up years they could do it on their campuses and the like, and we can see this. It's a great opportunity for saving money and using it more wisely. Before the ERA funds in the Obama administration, coming out of the Bush and the Obama administration, the renewable energy budget for Indian country, all 565 tribes, was something on the order of less than $10 million. And usually it was half of that or less. Earmarks took it out. $3 million for all 565 tribes. And that money, because no Indian reservation is manufacturing wind turbines yet, some are starting to do PV, but not a big industry there. Most of that money comes in from the feds and gets spent out for the technology. It's just a pass-through. And the same thing with housing. A lot of that money comes in and then goes right back out for prefab houses and the like, those kinds of materials. Some of it is used locally, mostly for repair of the existing houses, from the water damage, from the wind damage, from the fire damage, repairing and going on to that stuff. We could eliminate a lot of that and recirculate that money in the local economy for building a better built environment on the reservation. There's a couple more slides. They're there for you on the web, but just to give you some idea, the training that goes on, getting tribal people involved in these areas, training up crews. Again, the Art Institute, we can get them engaged in some of this plastering design. Great stuff. And these are jobs that if you can do this on the res, there's going to be people off the reservation going to want quality houses as well. And let's find a way to get there. This efficiency piece compared to Adobe for straw bale. Adobe as mass operates a lot like a teapot. You can't hold the teapot full of boiling water. Got to hold the handle because the heat goes right through mass and radiates out. An Adobe sitting at middle of winter in the desert, you take an infrared photo, it's going to look like a jack-o'-lantern, just glowing. We want a house to operate more like a thermos bottle. You don't know what the temperature inside is. It's the greatest invention in the world. You know that, don't you? It keeps hot things hot and cold things cold. No moving parts. How does it know? It just does it by the nature of the insulation going on there, the vacuum in there. So let's use this principle in our houses. Right now we use insulation, and we find here that a lot of this insulation doesn't perform to R19, because if you cut holes in it for electricity or plumbing, the R goes down, R value goes down. You've got holes in it now and sort of thing. You don't have that in straw bale. You can get an R40. Thermostats, they break. No one knows how to operate those new complicated ones. People who've got their VCRs that still say 12 all the time, you can't figure out that programming. The building does it for you. Your solar gain in the summer is reduced by these high overhangs. And then in the winter, you're able to get all of the south exposure solar. So you design your house for that. And you can end up with a nice quality house that doesn't cost you anywhere, maybe 70% less than you'd pay. That's money that left in your pocket, and you've got jobs building them. So that's what we're looking at for Indian country in terms of this building resilience. I'm over time a little bit, but I thank you all for your attention. Sir.
So has anybody analyzed the historical markers, the big snow year on the top of the TV poles and so on back, to look at climate variability in the past versus climate variability now?
Who wants a dissertation topic? We'd love to. I mean, we've got this kind of data. I've gone through some and got some general issues with years. It's easier for things like, there's some of those years we call flooding in several places. There's some years where you may find that actually one of them has the teepees up and brush piled around it. And it was said that this is because it was so dry, the plants were dying, but it became so dusty and sandy, blowing, that they banked this stuff around the houses because of that. So these are proxy measurements, sort of indicators of what the climate may be like. But to answer your question, the North Central, was it the EERC, I think it is, up in Grand Forks, North Dakota. They are funded by the Lignite Coal Council. So they had an interest in climate change, a bona fide scientific interest in climate change. And they were looking at natural variability, not the human fingerprint on it all, just what does nature do? And one of the most interesting things as a cultural ecologist and anthropologist was to find out that what they found by doing lake sediment sampling, going back to the time of Christ, 2,000 years, looking at the samples of lake sediment, cutting that up every year, just like tree rings, sort of, but the other way. Anybody see pond scum? You ever see pond scum in the summertime? It's all that pollen from everything that's around, lands on it, gradually sinks, and every year it piles up differently. Well, they've analyzed the pollen in the sediment and are able to determine what plants contributed in proportion to other plants and how that changes. So you can see whether it's a grassy area or more trees or shrubs or transitional. You can start building a climate proxy as to what climate those plants would have needed to be able to be there. You can build that up. And what they found, by and large, is this big sine curve of sort of wet periods, little droughts here and there, and then overall dry periods, little wet spikes, and then wet periods, and then dry periods. And they would last maybe a century and a half. What I find interesting is that in terms of natural variability, we, Western Europeans, have settled the West in the last 150 years, the last century and a half. It happened to be the wet period. We had the little droughts here and there, but by and large, we always get back to normal, the wet period. Well, that's our normal for the limited amount of time that we have experienced and been here. Indian folks have been here for thousands of years, and they've seen these swings, and their cultures have adapted to those swings. They understand that. We have not. Our experience has been the last 150 years, and we'll get back to normal, don't worry about it. What's plan B if natural variation simply continues and we go into a century and a half of drought? And that's before we ever mention the word. We're not talking about that. We're just talking natural variation. You compound that with global warming and climate change, we're in for a hell of a ride. I've had 2 heart attacks. My second one, I'm in the hospital thinking, what are you doing wrong? I realized I was suffering from PTSD, pre-traumatic stress syndrome. I've been worrying about things that haven't happened yet, but I know they're coming. I know the pipeline is loaded, and it's heading our way. And there's a sort of sense of urgency, which is why I could tell you all of the stuff in an hour, in 10 minutes. And I'm delighted to be able to have that opportunity, but that's sort of where we are now. But if students want to pick that up and study that, write reports and theses, all to the better. Any other questions? Yes, ma'am.
I know you talked about the proposed study you want to do next, but have you seen anything that talks about what winds are going to do with future climate change?
What winds?
Yeah, I've seen, temperature and precip, but not much about wind.
Right, and this is the more subtle stuff that we need sharper scientists to be looking at and asking those questions, because we know that winds are temperature related. Shifts in the colder air in the north and the moister air coming from the south, and where they mix is on the Great Plains. That's where we get it. So we get that kind of weather patterns coming from temperature differentials of those. And how that may shift, we need more people studying that with sharper pencils. But we can tell you now that the winds have certainly increased. We're seeing more summertime winds, even in the last 20, 30 years, than we had in the past. It's been more nighttime winter winds, by and large, and we're seeing more summertime and daytime winds coming through. So, and that's just sort of, it's not the, you can't make those averages yet. We're not there to make that determination, but that's what we're noticing with more and more people actually measuring wind for wind projects. And they're getting these wind roses back and saying, well, that's what we're looking at. Anyone else? There's a question. All right. Thank you all very much.